Hello, this is Professor Eric Steinhardt, and I'm going to talk to you about infinity. You can learn more about me at www.ericsteinhardt.com. Let's start with the natural numbers. The natural numbers are the counting numbers: 0, 1, 2, 3, 4, 5, and so on. Can you count through all these numbers? Can you count to infinity? Let's think about counting all the numbers. If you can count all the numbers, then you could count to infinity. You've counted infinitely many numbers. You might say, no, you can't count to infinity because the numbers go on forever. But the numbers don't go on at all. Numbers just exist. You mean that if you were to try to count through all of them, you would have to go on forever. And since you won't live forever, you can't count forever. Therefore, you can't count to infinity. Counting through all the numbers. Well, what if you were to live forever? No matter how long I count, there will always be one more number. So even if I count forever, I'll never get done with counting through all of them. Can you count to infinity? Here's an argument that you can't. If I were to count through all the numbers, then I would have to finish counting. If I finish counting, then I must stop counting at some biggest number, which is the last number that I count. But there is no biggest number. Therefore, I can't finish counting. Therefore, I can't count through all the numbers. Therefore, I can't count to infinity. What if you drank a lot of coffee? That would make you accelerate. You'd go faster. What if you speed up? Count each next number twice as fast. You count to 1 in half a minute. You count to 2 in just another quarter of a minute. Count to 3 in just another eighth of a minute. 4 in another 16th of a minute. This is acceleration. You take a half minute to go from 0 to 1. Then you take another quarter minute to go from 1 to 2. The total time you've spent counting so far is 3/4 of a minute. So, in half a minute you say 1, 3/4 of a minute you say 2, add another eighth of a minute, and you say 3 at 7/8 of a minute. You'll say 4 at 15/16 of a minute. You can always keep going. That little space between 15/16 and 1, that's 1/16 of a minute. But it opens up down at the bottom there. In the middle, it's got 31/32 of a minute, then 63/64 of a minute, then 127/128 of a minute, and so it goes. This is a series of fractions, the Zeno fractions: 1/2, 3/4, 7/8, 15/16, 31/32, 63/64, 127/128, and so on. The Zeno fractions have a certain structure. A fraction is a top number divided by a bottom number. In a Zeno fraction, the bottom number is always a power of 2. 2, 4, 8, 16, 32, 64, 128. The top number is always gotten by taking the bottom number and subtracting 1. So you have 1 over 2, 3 over 4, 7 over 8, 15 over 16, 31/32, 63/64, 127/128, and so on. The Zeno fractions have a pattern. Bottom minus 1 divided by the bottom. And since bottom minus 1 is less than the bottom number, the whole fraction is always less than 1. Every Zeno fraction is less than 1. So if you say the nth number at the nth Zeno fraction, then you've set it at some time less than 1 minute. If you count by accelerating, then you say each next number at the time of the next Zeno fraction. You say the number 10 at the 10th Zeno fraction, and that's less than 1 minute. You'll say the number 1 billion at the 1 billionth Zeno fraction, and that's less than 1 minute. If you count by accelerating, then for every finite number n, you say that number at the time of the nth Zeno fraction, and that's sometime less than 1 minute. So, if you count by accelerating, then for every finite number n, you have set it at some time less than 1 minute. Therefore, At the time of 1 minute, you've already said every finite number. Therefore, you've counted through all the finite numbers. Here's the conclusion. To count through all the natural numbers, 0, 1, 2, 3, 4, in 1 minute, just accelerate. At 1 minute, you say infinity, and you're done. Thank you. That's been the discussion of infinity.